Hi there, welcome. This is Regina. In this video, I want to show you how you can use properties of logarithm to solve for a variable that is an exponent. But first, let's look at a couple of graphs here. This graph here is an exponential graph. And imagine a graph y equals x, and the exponential graph is reflected in y equals x. The equation for the exponential graph is y, or f of x, is equal to a constant raised to the power x. Now, if you reflected it into the y equals x graph, the equation is y is equal to log base ax. Both a are base numbers, here base a to the power x, here log base a to the x. The logarithmic graph and the exponential graph are actually inverse of each other. And algebraically, you can go from one form to another. If you have log of base ax equals y, and if you wanted to convert it into the exponential form, all you have to do is take the a and across the equal sign and raise to the power y. And you now have an exponential form. You can also go backwards to the logarithmic form. Take the base back on the other side of the equal sign and add a log, and the y goes back down again, and that's your logarithmic form. I have a problem here where I want to show you two different methods of doing it. The problem is 8 to the power x is equal to 32. Now, I could go ahead and think of a base 8, which can be a 32. I cannot think of a base 8 number, because 8 to the power 1 is 8 and 8 to the power 2 is certainly not 32. We can get a little clever and think of 8 as a base 2 number. So 8 is a base 2 to the power 3 raised to the x, and we can't think of 32 as a base 2 number. 2 to the power 5 is 32. Laws of exponents will tell you to multiply 3 and x. So simplifying this gives you 2 to the power 3 to the x is equal to 2 to the power 5. Now, if the base numbers are the same, then the exponents are the same. So you can set 3x is equal to 5 and x is equal to 5/3. I do want to introduce to you one rule, and as we go through this video, I will introduce to you other rules that we need. But here I have log, and the green is a base number. So I'm just going to say log base green x to the power b. What I want you to notice is that the base is in an exponential form, x to the power a, and the number is also in an exponential form, x to the power b. Notice that the base numbers are the same. It's the exponents that are different. If you see that, then the answer is simply the top exponent divided by the bottom exponent. So let's go ahead and convert our original problem into the logarithmic form. Simply take the 8 across the equal sign, x goes back down, log comes back, log base 8, 32. Since we don't have a calculator to work with, we can be very clever and turn 8 into an exponential form, 2 to the power 3, as long as we can turn 32 into the same base exponential form, 2 to the power 5. And this is b and this is a, and we get 5/3. So I want to introduce to you another logarithmic property, which is the change of base formula. If you notice, if you looked at your calculator, you realize that you only have two base given. One of them is ln, which is essentially log base e, and the other one is log on your calculator, which is essentially log base 10. Any other base is not given in your calculator, but you can use the change in base formula, and I have generically put c and b here. So if you want to calculate log base c, where c is neither e nor 10b, then you can pick one of these bases and then say log base a, b, divided by log base ac will give you the answer. So in this particular problem, 3 to the power 2x minus 5 is equal to 13. convert it into logarithmic form, and you end up with 2x minus 5 is equal to log base 3 13. You will not find log base 3 in your calculator. So you pick either one of these two bases, and I picked base 10. I actually picked ln, which is log base e. So ln 13 divided by ln 3 gives me 2.3347. And I've actually shown here that if you pick log 13 divided by log 3, you'll still get the same answer. So either one works. And I have on my calculator, I figured this out, and that's the answer right here. And you can solve for x quite easily, and the answer is 3.66. Continuing on with our rules, I want to introduce to you another rule and remind you what ln is. ln is log base e. ln on your calculator is log base e. If you have log base a to the power r, the answer is simply r. You can think of this as a to the power 1. So it is actually the ratio of the exponent. So r over 1 is r. Here's a problem. E to the power x minus 1 is equal to 4. Let's go ahead and use another rule here. I want to log base e on both sides. And the reason why I chose to log base e on both sides is because I wanted to take advantage of this rule here. Because this is e and this is e, and if I go log base e to the power x minus 1, I simply get x minus 1. And I know log base e is ln on my calculator. So I get x minus 1 is equal to ln 4. I plug ln 4 on my calculator and solve for x, and I get 2.39. How about this problem? You might want to pause your video and see if you can try it on your own. Or you can stay with me. I want to divide both sides by 10 first. So I get e to the power 3x minus 7 is equal to 0.5. Again, if I picked to log base e on both sides, I will be able to take advantage of my rule of simply turning that into 3x minus 7. So I now have log base e 3x minus 7 is equal to log base e 0.5. As I've explained to you before, the left-hand side simplifies to 3x minus 7, and the calculator can handle the right-hand side. And x turns out to be 2.10. Next problem is very interesting. The question is 16 to the power x plus 4 is equal to 8 to the power 3x minus 2. Let's go ahead and see how it's done. I'm just going to remove my cover here. So first, we want to convert the exponential form into the logarithmic form by taking the base across the equal sign and bringing the log back in. And we get x plus 4 is equal to log base 16, 8 to the power 3x minus 2. I want to take advantage of my rule, which was log base x to the a, x to the b is equal to b over a. I turned 16 and 8 to the same base number. 2 was convenient. 2 to the power 4 is 16. 2 to the power 3 is 8. And before I applied my rule, I wanted to simplify my exponents here. So that's how I got log base 2 to the power 4 is equal to multiply 3 by 3x minus 2. You get 9x minus 6. And then you can apply this rule here. This is b, and this 4 is a. So the whole problem now looks like x plus 4 is equal to 9x minus 6 divided by 4, b over a. We're back to simple basic algebra where we can solve for x. First, I want to remove my denominator by multiplying both sides by 4, and I get 4x plus 16, and solve for x, and I get 4.40. Okay, it's time to learn another rule. Let's go ahead and look at this problem here. It says 2 to the power x plus 3 is equal to 5 to the power x. Typically, we've been converting this exponential form into the logarithmic form. But you notice that if I did this, I'll end up with log base 2, 5 to the power x. And we cannot convert 2 and 5 to the same base number. So that's not how we can solve the problem. We can try to pick one of the two bases, and I'd pick base 2 and utilize the rule we learned before back over here. We can use this rule where the bases are the same. The answer is simply the exponent. So my strategy would be to pick base 2, log base 2, but you have to log base 2 on both sides. So you log base 2 here and log base 2 here. And on the left-hand side, we have simplified it to x plus 3. Now on the right-hand side, we have not simplified a whole lot, but we do have another rule which we can use. And I want to introduce this rule to you now. If you have log base a x to the power something, it can be simplified to p log base a x. So we can bring the p back down here. And that's what we will use here. If I've logged base 2 on this side, that allows me to bring the x back down here. So the whole problem reads x plus 3 is equal to x log base 2, 5. The log base 2, 5 now is not a problem because we can use change in base formula we learned before, log base 5 divided by log base 2. In our calculator, we get 2.32, and we have x plus 3 is equal to 2.32x, and we can solve for x pretty easily. What you can do in your own time is to plug 2.27 back here, use your calculator to figure this out, plug 2.27 back here, and you will realize that the answer is the same. They both should give you 38.61. I think I'll stop here, and I will see you in my next video. I hope this was helpful. Thank you very much. I'll see you again. Goodbye.